virtual machines are heavyweight while containers are lightweight? First of all, you need to understand how the operating system architecture works. Here, Ray is actually explaining about operating system architecture. The operating system having two major components, that how application runs on this kind of architecture. But my question is, you explain all this based on the physical machine, right? How does this works when we use virtual machine in the cloud or data center? Get ready for some exciting learning. Hello and welcome to CloudFolks HUB. My name is Bhavesh Atara. If you want to become master of ECS, Elastic Container Service, you have to understand container first. And if you want to understand container, you must have clear idea about virtual machine. As you know that, today Ray is going to explain everything about virtual machine to Leo. We are going to join this session to understand virtual machine terminology. So let's start. Ray keeps his promise. Early morning, he called Leo and said to him that, okay, I am ready to explain you virtual machine. If you are ready, we can start. Here, Leo's reply is really very important. Leo said that, now I realize why this is important, why we need to understand virtual machine. Because of Leo's one mistake, everything was down, right? You remember about the first session. By mistake, Leo added third application to its EC2 instance, enrollment app. And because of this enrollment app's too much utilization of the resources, everything was down. And because of enrollment app, Leo's LMS and support app was also down. So Leo was actually looking to understand how these virtual machines are actually working. Now here, Ray raised one important point. Look, I'm going to explain you the entire process of virtual machine. But keep this in mind that you are using modern technology of AWS EC2 instance. Right now, do not consider this. Do not add this into your learning process. What you have to do here right now, you just need to assume that you have three applications like your LMS, your support app, and your enrollment app is actually loaded into the one physical machine in your data center, right? I will talk about EC2 instance in upcoming days. What is EC2, how virtualization works over there, we will discuss about it. But right now, for current understanding, you have to assume that you have all the three applications loaded into one physical machine. Okay, got my point? Now, let's understand about the problem if everything is in one machine. Ray said, you had the LMS existing application, you have support app, and then the third one, the enrollment app. You added all this into the single physical machine. Here I have this particular picture. Look at this. You have one physical server. Physical servers are actually combination of main four parts of hardware: CPU, RAM, storage, and networking. Now it can be a small laptop computer or any desktop computer, or even in the server. When we are going to talk about physical server, it is actually combination of all these four parts. Now on the top of our physical machine, we are actually installing operating system. Now this operating system having main two components. One, kernel, which is actually going to talk with the physical hardware, and application layer, which is communicating with your application. Now if you look at this particular current setup, you will find out that all your applications are having common or shared physical server, kernel, and application layer, right? This is our current scenario. Now what happened if one of the application, let's say that your enrollment app starving all the resources, it is going to affect on support app and LMS app as well, because it is possible that they don't have resources to utilize. Now this is actually problem with this kind of setup when you have installed everything into the single machine. Leo replies, we had no resource boundary, everything fails together. If your server goes down, everything will be down as well. Rio says, that's a classic single point of failure because you were sharing operating system, kernel, and even system resources among all of these three applications. Now, what I am doing, I am going to explain you about some limitations, right? Let's say that why physical separation isn't practical. According to the rule, what Rio is saying, according to rule or according to the best practices, you should separate all the three apps, each on their own server. It means you have to purchase 3 physical server and you can run your 3 different applications on the each server. As you know that Leo is a founder, always looking to save money. So what Leo is saying? But that means 3 physical servers, expensive and hard to manage. You know, if we are going to talk about electricity bills, you are paying for 3 servers, you are paying for 3 annual maintenance contracts. So your expense will be very high. Now what Ray is saying exactly, and that's where virtual machines help. If we are talking about the era between before 2000, we can say that this was the scenario. If I have 3 different applications, I want isolation, I have to purchase 3 physical server and then I have to run this application, each application into the different physical servers. But virtual machines solve this problem. How? Let's understand this from the Ray as well. So now we are going to discuss about what is virtual machine. Let's break down how virtual machine works step by step. Now this process is really very important and you need to understand this. Okay. Now we started with the step number 1, start with the physical hardware. In any case, we have physical computer required. Even if you are going to use virtual machines are always hosted into the physical machine, right? So physical machine is always there, which is your base. And the physical machine having real hardware, CPU, memory, storage, and networking, right? Now, because we want to create multiple virtual machine over here, we have to install hypervisor. On the top of physical server, you have to install hypervisor. Now, hypervisor is a software which allows you to create multiple virtual machine. In the year 2000, VMware developed this. VMware's hypervisor is known as ESXi. Microsoft also having this, they call it Hyper-V. AWS is also using hypervisors for EC2 instance. They are using Zen or Nitro based virtualization process. Now this hypervisor is kind of installer which you can install directly on the physical server. So we call it like a bare metal installation. You can directly install on a physical server. Same like you are installing operating system on your brand new laptop. Now whenever we are learning this process, don't worry that how you are going to install this and the practical steps, right? You just need to remember that if you want to create virtual machine, we have to install hypervisor. We can install hypervisor directly on our bare metal servers. There are many types of hypervisor like type 1, which is bare metal. You can install directly on a physical server. There are also hypervisor like type 2 for For example, Oracle VirtualBox, VMware Workstation that you can install into the operating system as well. But we are not talking about this hypervisor. We are talking about type 1 that we can install directly on our physical server. So you have physical server, because you want to create multiple virtual machines, you just install hypervisor on the top of your physical server. Now, step number 3, create virtual machine. Using the hypervisor, you can create multiple virtual machines. Let's say that if I'm using VMware ESXi, once you install this VMware ESXi hypervisor, you have to provide IP address to your hypervisor. Then you can access this hypervisor graphical user interface from any PC through the browser, and then it will allow you to create virtual machine. But again, I am saying you don't worry about practical. We are just understanding the entire overall process. So hypervisor will allow us to create multiple virtual machine into this particular physical server. The hypervisor provides VM with virtual CPU, virtual RAM, virtual disk, and virtual network. See, once you install hypervisor having full control on all your these components like CPU, RAM, storage, and network. Then it is going to share these components with virtual machine. Now, whenever the hypervisor will provide these components to virtual machine, we call it vCPU, means virtual CPU, virtual RAM, virtual disk, and virtual network. Now, this will be like scenario. So here we have our physical hardware, then all this hardware is actually inside the physical server. We install hypervisor. Hypervisor will allow us to create virtual machine, and hypervisor will provide virtual components to all these virtual machines. So if I'm going to talk about this CPU's icon, it is actually shared CPU of this physical, we call it virtual CPU, right? This makes each VM thinks it has its own hardware, though it's shared. Definitely these virtual CPUs are shared from this physical CPU, but all these VMs, VM 1, 2, 3, they are always thinking that I have my own CPU and they cannot cross the limits of this. Let me give you one simple example. Let's say that I have 8 GB of RAM here in the physical server. I created one virtual machine, I provided virtual RAM to this VM, and out of 8 GB, I just assigned 2 GB RAM to this VM. Now this VM will think like, okay, I have 2 GB of RAM in my system. It means it is not going to cross this limits of 2 GB, right? Now, once you have your VM ready, the step 4 is installing operating system. So inside this VM, you are actually going to install operating system. Now, one thing that I want you guys to understand, there is no different operating system for physical machine and virtual machine. Whatever the operating system and ISO image that you are using to install operating system on a physical machine, you are using same ISO image or operating system here in the virtual machine as well. So there is no difference between virtual machine and physical machine operating system. These are like the same thing and same process to install. And as you know that we already discussed, Ray explained us that for all the operating system, we have mainly two parts, kernel and application layer. Now look at over here. We have kernel and application layer for virtual machine 1, kernel and application layer for virtual machine 2, kernel and application layer for virtual machine 3 as well. This will be like a same as physical machine. We can say that in one particular physical machine, we have 3 virtual machines, acts like a physical one, right? The OS will have on kernel and on application layer, means same as our physical machine. Now, what you are doing in the physical machine after installing OS? We are installing application. Now look at this scenario. Here we have operating system, then we install our LMS app into the separate VM, support app into the separate VM, and same we have enrollment app. Now this is called virtualization scenario. I want you to check this out as well. This is virtualization scenario, right? Now if I am going back to the main part of the physical machine, you can easily identify the difference. Okay, so that's why I'm just doing this exercise. Look at this.
Sorry to interrupt you. I know you guys are enjoying our video a lot because our final ultimate goal is Solution Architect Certification exam. To reach the destination, we required full videos. To create our success story, here we have a 3 path. You can choose any of them. Path number 1, our 6-in-1 program. Our 6-in-1 program include all prerequisite skills which is needed as a cloud engineer. It include 24/7 support, lifetime update, section-wise practice test, full course practice test with tips and tricks by Bhavesh Atara, how to do exam preparation course, weekly lifetime live session with Bhavesh Atara, and 6 AWS project with documents. Path number 2, you can enroll by paying 499 and get Hindi and English, both the languages, videos of AWS. Path number 3, which is the last one, you can join our YouTube Elite membership. The choice is yours how to create your success story by choosing best one. Best of luck. Thank you.